Welcome to the Unity BootCamp lesson on requesting global entities by indexed ID. In the previous lesson, we created 4 global entities on the brainCloud portal that will be used in this lesson. In our Unity example app, we're going to request a list of global entities using their indexed ID. Let's take a closer look at the getList by indexed ID brainCloud request. We can see that we need to supply the entity indexed ID and the max entities to return. Taking a look at the return JSON example data, we can see that we have an array of global entity objects that will need to be parsed. This is the same brainCloud request that we made in the Cloud Code API Explorer at the end of the previous lesson. Open Visual Studio and navigate to the constant script. Declare a constant for the level global entity indexed ID. Save the file and navigate to the level data script. This class is responsible for keeping track of the level control data used by the spawner in both endless and horde modes. At the top, add a using directive for braincloud.lit.json. Scroll down and declare an overloaded public constructor that takes in the entity type, entity ID, index, and a reference to the JSON data. In the body, initialize the entity type, entity ID, and index member variables. Then declare 3 lists to hold the enemy types and the starting asteroid and enemy types. The rest of the constructor will parse the level JSON data. All these values that are being parsed will be used by the spawner class to spawn asteroids and enemies at the appropriate speed and intervals. Save the file and navigate to the network script. Declare a pair of public callback delegates that will be used to handle the response for getting a list of global entities by their indexed ID. Scroll to the bottom and declare a public method called requestGlobalEntityLevelData. In the body of the method, check to see if the user is authenticated. If the user is not authenticated, log a meaningful error message, and if set, invoke the failed callback delegate. If the user is authenticated, declare success callback lambda. In the body of the lambda, log the response data. Declare some local variables that will be used to store the global entity data, including a list to store the level data objects. Create a JSON object from the response data, and then get the entity list array. Loop through each entity in the array. Parse the entity type, entity ID, and the level index. Then get the level JSON object. Create a level data object passed in the entity type, entity ID, index, and a reference to the level JSON object as the arguments. Push the level data object onto the level data list. Remember, the level data constructor will finish parsing the rest of the JSON data. If set, invoke the completed callback delegate. Pass in a reference to the list of level data objects as the argument. Next, declare the failure callback lambda. In the body, log an error along with the status message, and if set, invoke the failed callback delegate. Finally, make the brainCloud's global entity services getList by indexed ID request. Pass in the level indexed ID constant, the number of values to return, and the success and failure callback lambdas. Save the file and navigate to the game class. Scroll all the way to the bottom. Declare a private method called onGlobalEntityLevelDataRequestCompleted. In the body of the method, invoke the spawner's setLevelData method. Pass in a reference to level data as the argument. Then loop through the level data list and get the level durations and the level descriptions and store each in the respective member variable list. Finally, hide the connecting dialog and show the main menu. In the onLeaderboardRequestCompleted method above, delete the else statement and its contents. We are now doing that logic in the onGlobalEntityLevelDataRequestCompleted method instead. Scroll up and find the onAuthenticationRequestCompleted method. Invoke the network's requestGlobalEntityLevelData method. Pass in the onGlobalEntityLevelDataRequestCompleted method as the argument. Save the file and then navigate back into Unity. If you need to perform a manual refresh, do so now. Run the game. Select Horde Mode, then select Level 1. The asteroids and enemies are spawning based on the global entity data that we created for Level 1. To save time, the playback has been sped up for Level 1. Level 1 is complete, on to Level 2. The playback speed will not be sped up for Level 2, so that we can compare it with a future playthrough of Level 2. On the first playthrough, we didn't even survive for half the required time. Perhaps we made this level too difficult. Stop the game, open your web browser, and navigate to the brainCloud portal. We're going to tweak some values with the Level 2 global entity data. Click the Level 2 global entity. To make changes, we first need to click Edit. We aren't going to change the asteroid data, but we are going to make a few changes to the enemy data. First, we're going to change how many enemies spawn at one time. Then we'll modify the min and max enemy spawn times. We'll lower the max enemy speed. And most importantly, we'll remove the fourth enemy type. Once that's done, click Save. Let's return to Unity and test these changes. Run the game. Select Level 2 from the Horde Mode dialog. The playback speed will not be sped up, so that if you want, you can compare it to the previous playthrough of Level 2. Playing through Level 2, I think we might have actually made it too easy. But that's okay, we can always go onto the brainCloud portal and make tweaks to our level data at any time. How to set up user statistics is the next lesson in the Unity Bootcamp.